Good afternoon to all. We are now going to start our session, second session of the final day. This is the 5th day. So there is some change in the schedule. We are unable to have the speaker, Dr. Smita Mohanty, due to some unavoidable circumstance. So the speaker for today's session will be the one whom you all have interacted from the beginning. She is none other than the host or who has interacted with you all, Dr. Santoshi Mohanta. She has PhD from IIT Kharagpur and over 5 years of research experience in polymer composites. So now let us welcome Dr. Santoshi for this session. So those who have not joined, please join. We are going to start the session.
Thank you, sir, for your kind introduction. Let me share my screen. So my slides are visible. Good afternoon, everyone. I think all of you have joined. Or we can start our session 5 minutes later. It's up to you. You can write in chat box. Today's topic is plastic and a better world. So till now we have seen, or this whole FDP program is about recycling of plastics for sustainable growth. So I think almost 8-9 sessions we have discussed about how to recycle plastic or how the plastic wastes are getting generated day by day. It is a like burning problem in our society or at the present day. Then also we are hoping, as we are human beings, we always believe in hoping for best and taking even from minimum we can extract the maximum. So then also after getting or after facing so much problems related to waste generation of plastics and how it is creating problem to our society, still we are trying to look in a different aspect and we are trying to give another perspective towards plastic for a better world. So that is what I'm going to discuss with you today. If anywhere you people are not able to understand anything, basically I am not going to give you any research related articles. So anywhere if you people find any doubt or need any clarification, at that point you can ask me. So plastics, because all these sessions or the theme of this 5-day program is about plastics and to recycle plastics. So what is this plastic? Yes, I think everyone knows what is plastic, what is composite. So okay, let me read out the basic definition. Or basically in our day-to-day life we are using many numerous plastic applications, like whatever we are touching or seeing is a plastic product. But when we are going to define it, at that time we have to think, we have to rethink what it is. So exact definition of plastic is not popularly known to all. we only identify plastic from its applications. We don't bother what it means. So plastic is a term which is basically, if we go for the dictionary meaning, then it is previously used to explain a kind of medicine which is used to provide or used to give in such diseases where we have where basically our brain, or we have to face some kind of behavioral changes. So plastic is something which undergoes behavioral changes, or which undergoes changes to some kind of external stimuli. So from that definition, we have given, nowadays we are giving the terminology, or we are using this plastic as the material which can be molded, which can be reshaped, which can be basically given any type of, or have the tolerability property. So plastics are such kind of materials, or plastic itself is has some different meaning, but when it is coming to plastic materials, then it is giving you the material definition, or which can be reshaped or remolded. So these plastics are extracted, or these are the basic source of plastic, are basically the fossil fuels. And we all know, basically from our petroleum sources or crude oils, this plastic is, or polymers are extracted by fractionation. So when there will be fractionation or extraction process, there will be one part will be collected as polymers, and depending on their type of monomer arrangement, there will be different type of polymers itself. One will be the basic or preliminary classification will be thermoplastic, and another will be thermoset. I am not telling there will be branched polymer, there will be linear polymer, there will be copolymer. So other classifications are there, but the basic, or in general convention, what we make the classification way is based on the temperature, or how it is responsive towards temperature, and depending on that we classify it as thermoplastic as well as thermosets. So thermoplastics are those which are basically where the monomer units are linear, or basically the linearly branched, linearly chained monomers are there, or polymers are there. So thermoplastic are those when you have when you apply some temperature, they can be reshaped, or they can be melted, and then you can give them a different form, and then again when it cools down, it will be hard. Then if you want to recycle it, or you want to reuse it, then again you can apply some heat, you can again change the shape of this particular product. So thermoplastics, common examples you have seen in day-to-day life. There are many single-use plastics are made of thermoplastics, and similarly thermosets are those which undergo a permanent deformation on application of heat. So these are basically some cross-linked polymers. So when you apply some heat, there will be cross-linking or polymerization will take place, and they becomes they take a rigid or a hard structure after the polymerization overs. So one, this reaction or curing polymerization reaction gets over, you have some product which are hard in nature and which cannot be further reformed or reshaped. So the common examples you might have seen the bakelite, or there will be phenolic resins or epoxy based products. So there are many. So similar to your plastic, because we have to discuss about the plastic for better earth. Similarly, another part of plastic is fiber reinforced plastic. So there you have only the polymer part. But when there is fiber reinforced plastic, you have another component which is the fiber, or basically reinforcement. So here it is, from the name itself you can understand there will be fibers which will be reinforced in plastic, or basically in polymer. So there are two components, or there are two different materials. One is your polymer, another is your fiber or reinforcement material. So these reinforcement materials can be your glass, ceramic, then there will be fibers, there will be carbon fibers, there will be many other sources of fibers are there. Depending on these fibers, you can get a composite product. You have two different individual components and you are combining it to get a newer product, fall under your composites, and composite will give you a enhanced or super property compared to either the polymer or the fiber itself. When you compare with the individual component, your composite will give you a better product, better. So that is why these FRP composites are like another branch or another aspect of your plastics. So plastics and FRPs go side by side. But when coming to cost analysis or the method of manufacturing or production, both will have different methods, but it is hugely dependent on polymer is getting developed over year, or how like your FRP usually dependent on the development of your polymer, because your base material is polymer. So you have seen these FRP composites or FRP in your day-to-day applications. Like there are many, from your mobile cover or your laptop cover or the desk bench or chair or anything you might have seen in your day-to-day life are basically either glass reinforced composites or carbon fiber reinforced composites. So the application of plastic is, as well as the application of composites are also overwhelming. These, or where is plastic or where is FRP, I was discussing now, like everywhere you will find these FRPs as well as plastics in day life. So as I have given a question, if the answer is everywhere, then it is fine, absolutely fine, because we are at a stage where it is impossible to think a particular product which is not made up of plastic. So plastic is something which we are very much dependent on our day-to-day life. Similarly, the FRPs. So this age or this era, what we are living now, is basically termed as plastic era or plastic age. You can see there are some applications or images of applications I have shown here. This helmet is basically your, this is a product of sometimes glass fiber reinforced composites, or yes, this is basically a GFRP product. These are your straws, or in your daily life you might have seen the plastic straws. These are the polyethylene your carry bags. So there are plastics as well as there are composites. These are PVC pipes, and sometimes wiring are also made up of plastic. Sirens are sometimes made up of your polypropylene or your polystyrene. So depending on that, you can find various applications of your FRPs as well as your normal only plastic or polymeric products. So there are a few conventional materials or few conventional articles which are replaced by these plastics fully. Means 20 years ago or even 5 years ago, the product which we have used as metal or glass or ceramic are now being replaced by plastics, and we are using as a plastic product. Particularly you have seen those plastic cups or plastic pouches of water pouch. Particularly water bottle was a like age old, not age old, but we have seen him around 10 years back, but there are again plastic pouches are also there, which is like we are now getting used to it. So all these things are being like replaced, or a new type of material is taking place, all the replacing all the conventional materials. So when we are terming, or we are giving the name of this particular age as plastic age, then we can go back to our human history or the development of mankind. Then we can see there was, or each ages or each development, the mankind development stages are basically defined in the terms of your what materials they have used. So if you have some idea, or basically in our childhood days when we are studying history of mankind, then we have gradually started with stone age, then there will be the bronze age, then there will be the iron age. So one age to another age, you can find there is some minimum 1,000 years gap, or there will be sometimes 1,500 or 2,000 years gap is there. If this development takes place like from one age to another age, previously it was taking like more than 1,500 or 1,000 years. So you can see the timeline here, and you can confirm yourself that after iron age, or in our middle ages, after this particular middle ages, we have developed, or we have tried to develop, the mankind has evolved so much, then they have tried to develop some kind of steel or some kind of composites, some kind of newer materials, then there will be polymers. So there will be like, this is thoroughly a industrial era, or the industrial revolution take place. So our polymer, or basically the polymer which we are terming now, or the present age as a polymer age, has developed, or it got its name in this particular era. So now when we try to see what we have discussed, when we try to imagine how things were there when you have in case of your stone age, basically there will be the caves, or people or mankind were trying to stay, not trying to stay, they were staying in hills, or they were making the caves inside different mountains, hills, and they were staying, living over there. So in they basically using the uh, utensils, they were making the stone utensils, everything they were making with stone. So this thing was around 3300 BC. But similarly at that time, if you try to like, if you go into the history, then at that time there are some history, or some places, there will be the evolution of your bricks, or basically the your sand bricks from stone, these caves to your these bricks, those are around 100 years of gaps. But if you have seen the Mesopotamian this architecture, at that time you might have seen the this kind of architecture, or basically people try to build their houses with bricks. Then with the progress of our mankind, this is an image of our bronze age home, and this is an image of your iron age home, and this is the modern house which we are like nowadays we are going to see, or we are seeing. So in a modern house, there will be metal part, there will be wooden part, there will be stone part, there will be polymer part, or composite part. So in modern architecture, all these things are being used. Similarly, this is the house prospects, and when you go for composite applications, or when you go the development of composites, then you can see this line or these images. So composites are also when there are stones or stone is people, at that time only there is the concept of composite. But thing is that in composite, as we have discussed, there are two parts or two components. One is polymer, another is your reinforcement. So in that case, the polymer or the matrix material was not polymer. In that case, the matrix material was mud, and the reinforcement material was sometimes straw, sometimes some like pebbles. So they try to make bricks, they try to mix straw with your what mud, and they try to make some wall out of it, they make some bricks out of it. So the depending on the availability or our knowledge of material, we have tried to get the better version of ourselves. Similarly, when we evolved over years and years. The evolution of composites is also in a similar way. So when there was no polymer, that time the matrix was mud. When there was like some 1800, even 1200 year, at that time there will be your uh, some idea or some evolution of polymer has taken place. We'll be going in details of polymers also. So some development of polymers has taken place, so people have tried to develop some kind of boats or some types of yachts with the help of glue. They are using some glue which they can take from rubber plants, or they can use that and they can stick, or they can join two parts of your wooden parts, and they try to form the yacht or boats at your ancient ages. Then different, as we gradually go on, then a newer form, when you have the polymer at its best form, or basically we got the thermoset polymer in the year 1907. At that time we have such kind of product. Such kind of product means you have seen at your home those music recorders and other things have those are like very heavy, and if you what uh, sometimes by mistake not throwing it, but if it fell down by mistake or something like that, then it will basically break. But at that time the metallic part or the flexibility of the material developed was not that better. But nowadays if you'll find some such kind of radio or music recorder, then they won't break easily, you'll see that. Then the future is here, or basically if we are living in a plastic age, so we cannot leave this particular plastic, or we cannot forget the flexibility or usability what we got from plastic, and we cannot just leave this material and go ahead with newer material. We have to go with it, we have to find, or we have to use this material in future also, but in a newer way. Because you have seen in all these generations or all these eras, people have evolved by using their previous knowledge, not by discarding the previous product. So that is, so in future also we'll try to find some solution, or we try to improvise the material whatever available with us. So there are some history of polymers which I won't go in details, you can find in several literatures. Basically this image I have shown over here is first time when you have when like people got to see the advertisement of some plastic product. So this is a raincoat, the company, or basically this equiped. So they have shown this advertisement of coat in the year 1929. So that time this quote was first made, and after that, basically, after your if you go beyond that, then there will be some natural sources or natural rubbers are there. Different forms of polymers are extracted from basically your plants and other things, sometimes fruits, sometimes latex, sometimes gum and other things. But when you come after your 1838, or basically your 18 uh, yes, 1838, then after the huge revolution, within 50 years you'll find many plastic or many macromolecules have developed by different researchers and scientists, which at your later part are also awarded Nobel Prize. So gradually there are different parts, like sometimes it was natural cellulose was developed, then there will be cellophane developed. So gradually you can see the history of the development of plastic parts. But the main development, or what is the result of today's uh, condition, is happened in your Second World War basically. So at that time, your USA, before that, plastic was present in your USA and Europe market. It has not come to Asia. So at that time, when there was Second World War, people tried to develop some easier method, or in your defense base basically they tried to do some bulletproof jacket or make some bulletproof helmets, or some vehicles which should be somewhat lighter in weight. So they have tried, or they have opted for plastics or polymers. So that was the time when there was huge revolution in your plastic industry. So after that, after your 1930s, it came to our Asia and Asian subcontinents. So after that, your China is now, I'll say, the global, it tops in your global production of plastics. So even if we are starting late, but we are not going beyond, or we are not way behind them in case of your production of plastics. So similarly, if you, because I have told plastic and FRPs go side by side. Plastic is a newer product, but but composite is an age-old product. Only difference is that in composite we are using polymer now, so we are making FRP here. So this FRP composites, similar journey you will find. Like it is, as I have told, initially it was the bricks, and it was the composite boards, it was the boats, and many things are developed at your earlier ages. But after this development of your polymer, basically the world of composite has changed, and there are huge applications or products of FRP composites have developed. So after basically, then again there are development of your glass fiber and carbon fibers and many things are there. So as I was mentioning that there are various, there are from the beginning, or from 1930 onwards, or after your Second World War, there are many development in case of your polymers, because of some additional flexibility or some molecular rearrangement, giving some different theory, or basically the development of polymer chemistry, development of polymer generation. So in that case, you'll find numerous scientists, numerous researchers or physicists or chemists, they have won Nobel Prizes over this time. You cannot find such, or such a broader range of or broader number of scientists getting Nobel Prize for other materials, basically materials in the sense your metals or ceramics or other conventional materials. So what is after developing or after going back to the history and again coming to the plastic age, this is basically, I am trying to let you know that with the effort and with some motivation and many brainstorming activities and many dedication, we have come or we have this luxury to live a better life with the help of plastics. Because again, we cannot see a single product or single application where we are not using plastics. So you can see from this production or basically of your plastics, this is only for plastic I have shown over here. You can see that around 400 million tons of plastics are being produced, and that I think on our day one, Amit sir or someone else was telling that it might exceed around 6 million tons in our 2022. So the this production, this is like increasing way beyond our imagination. This is because of its flexibility, or you can say the advantages or the various application areas we are finding. So you can see the most of the your plastic whatever generated is used for packaging, that is fine, but there are many other areas, where plastics are used. 36% is used for packaging, which we are telling as a single use material, or we need to recycle, reuse, and other concerning parameters, other concerning things, whatever we are talking about, we are mainly concerning about this particular 36%. So what about the remaining percentages? The remaining percentages are, if you find again for composites, FRP composites basically, the market is something like this. Here also FRP composites are basically used for high-end applications like your transportations, then buildings and construction. Then there might be sometimes the solar energy panels and other things. So there will be renewable energy, there will be infrastructure, there will be chemical sectors, then telecommunication sectors, and there will be defense sector. So the composites or FRP composites, it is also gaining its popularity over years, and you can see how the production rate is increasing over time. So as the production level of plastic as well as composite is increasing over time, then how we can look for a sustainable environment, or how it will be good for our earth, how we can think of a better earth with so basically huge production of our plastic. So there is just a question, is plastic can good for environment? So basically we in our common sense we usually tell no, it is not good for environment. Then why we are using it if it is not good? If someone has told you that okay, that material is not good, this is poisonous, this is like harmful, this is carcinogenic, and then there will be plastic. So then why we are using it? Because it's pros, every material has pros and cons, but the in case of your plastic, the pros are again more compared to your cons. So as I have written over here, plastics are made from petroleum, then which is better in a landfill than in a tank of gasoline. So if you are keeping it or using it as a landfill, then at least you are using it. Or if it is kept in a tank of gasoline, that will give you the energy to basically it is a source of energy. But what about the rest part? During your this crude or basically crude oil fractionation, where this petroleum will go? You use the topmost parts like your gasoline, there will be your petrol, there will be your diesel, there will be kerosene, there will be other parts. But where this polymer or this part will go? You have to use it. So that use or that application we as a mankind are doing, and we are now telling that plastic is creating pollution. But what my intention or my uh, theme of this talk is that plastic is creating pollution, that is fine. But as we have seen this application area, there is a particular sector which is packaging. This packaging sector which is taking around 34%, that packaging sector is mainly responsible for whatever discussions we are making today. That is, this packaging sector is hugely responsible for that one. But why to blame other sectors? Because there are many other sectors are also there, which we are not claiming, which we are not trying to recycle or trying to reuse. Are we basically waiting till the time when the other sectors will also try to create problem or try to create some unwanted pollution, then after we'll give the attention to other sectors? It is not like that. The packaging basically the single use plastics, or in case of your packaging sector, mostly the single use plastics are used. So those are single use, means we are just using once. We are not trying to repeating. We are discarding after using it. That is why we are attending these sessions, we are attending this circular economy, we are trying to make some recycle, or we are trying to separate those parts and try to recycle those products. So how to do that, or how to think of the other parts apart from the packaging industry or the 34%? So remaining your 66% has your transportation, has your textile, has your medical applications and many things. So if we think of FRPs, if we go, we are not now considering the plastic only, if we go for the FRPs, at that time you have seen, or if you try to go through polymer history or polymer properties, then you can find the life of polymer is very high. If something, you have a product whose life is very high, then why to discard it so easily or so fast? So that is why the FRPs or fiber enforced composites, they are like used for defining or for developing a sustainable environment, in the sense that those FRP composites have some higher life, some, not some, those will be like more than 10 or 12 years compared to the normal metallic parts. But again, they have the superior property in terms of your strength, your mechanical strength, or the you can say the what else, corrosive resistance and many other parameters. You can find the FRP composites are superior compared to the conventional metals. So if you have a superior material, then go for it. Similarly, there are various sectors where the conventional metal pipelines or metal Metallic structures basically are being replaced by FRPs, like I am talking about in large scale. So in that case, if you have the FRPs, if you have the FRPs for, suppose the life of your FRP will be around 10 years or 15 years, at that case your metal will have around 5 years or at 8 years. So you can double the life of a particular component. It means your energy usage, or ultimately for developing for a particular application, you are developing a single component, and previously you have to develop two or three uh, what three products, two or three products, but now you are having only single product. So if you are developing only single product and you are getting benefited for 20 years, then what is more beneficial to you? Because in this case your total overall cost will be reduced, your energy consumption will be reduced, your raw material expenditure will be reduced. So all that aspect, if you see or if you analyze, basically in case of your economic evaluation or performance evaluation, then you'll find those FRPs or those plastic parts are directly or indirectly helping us to go for a sustainable earth. What do you mean by sustainable? Sustainable means something like, it is, what I'll say, it is basically you have to create a world which is sufficient, or you have to create a world which is dependent on its natural renewable sources, or it has some zero wastages. So those are the basic or crude meaning of sustainability. So if you are developing or dependent upon the FRP components or the plastic parts, and you are extending its life compared to the conventional materials, then ultimately you are leading in a sustainable, or helping the world to move towards sustainability. So those are few aspects, or basically few areas in which we can think plastic can help us to move towards the sustainability or a better world. So as we have discussed, or we take the advantage of durability of plastics or composites, or basically the life cycle of composites are higher. This is sometimes not desirable, or this is the problem when where people are thinking that plastic is creating problem, or plastics are creating pollution, because those are not easily breakable or easily decomposable, because those are their life is higher, so why they will decompose? So that is why we think them as a uh, or not, we are thinking, but it is creating pollution in that sense. So sometimes the life is advantageous, and sometimes this life of polymer is only creating problem for us. So why this life, basically if we have to think of a sustainable uh, earth or world, in that case we have to think of somewhat the reuse of plastics, or if it has a higher life, then why not to use it up to some, like 80% of its life? Why to discard it immediately after just using once or twice? So if you have, like, basically it is our common, nowadays it is a basically common practice to buy something and throw it away, just like after using it once or twice. So these are some behavior, those things I'll discuss later. Also some behavioral change we have to bring in our lives, so that we have to use the life or extended life polymeric products or polymeric plastics, and we can extract maximum out of it. So the problem is with because we are thinking plastics are not getting decomposed, they are not getting disposed easily. Even if we are trying to develop some biocomposite, for that also we have to provide, we cannot just litter it here and there. We have to provide a particular condition, then only they will compost or they will decompose. So you have to provide some external energy to dispose those plastics. So how to dispose these plastics, so that is the main concern. So there is what is problem with us is that we have this cherished possession. What is this cherished possession? What just now I mentioned, like this is our nowadays we have this common practice of purchasing anything in the sense from garments, from our household appliances, furnitures, from from a low budget to a higher budget. Even we are having mobile phones, three or four, we have laptops, we have everything, we are having in multiples, not in a single. Those watches and other things, previously those are considered as some precious, or if we think before 2010 or around 2005 6, at that time having a mobile is something precious thing. So we try to maximize its use, means if you have purchased it, you try to use it for 5 6 or minimum 5 years. We have that thought until it is not working, it has basically showed many problems. But what is happening now? Now we are seeing like because our technology is changing, because we are exposed to so many advertisements, so many newer appliances on our finger touch only we are able to purchase them. So every facilities we are using, and that is creating problem with us. That is why we have this tendency, like nowadays our behavior has changed, and the thing which was precious to us before 10 years is just a commodity to us now. So that is the problem with us. And there are some examples I have cited over here. One is one is mattresses, how the previous mattresses were different, or how those can be basically gets damaged with damp or moisture or something like that. But now, as we can have some polymeric mattresses which are basically, which you can use for 10 or 12 or 13 years. But then it comes, you don't want to use a single product for so long because you don't want it, so you will just throw it away. So you will throw it away, then it will go somewhere else, and again it will not decompose. So that is the problem is that we are not using something up to its minimum 80% of life. We are just using it for our basic time period. Then another more advantageous feature, or I'll say the critical application area is of plastic, is in improvement of medical appliances. Because in previously we are having most of the medical appliances are single use, should be single used, and should be sterile. So plastic products, the after those plastic products are being used for making your injections, making your syringes, making your those other appliances, those help to reduce the chances of infection. So in case of your, again, from medical, there are huge amount of your garbages are generating on your daily basis. And during your COVID time also, you might have seen there are masks, there are these what sanitizer bottles are thrown everywhere. So those are again a problem of us not to discard it properly. So if we try to discard, or if we try to use the maximum of it, then it will not create that much problem what we are facing now. So those whatever plastic products are getting discarded, those basically uh, landed or thrown away or littered, ultimately they come to the marine life, or ultimately they flow through different water sources. They block your water sources, and they go to and fall on your sea. So they more or less affect your aquatic animals if they are inside your like they are dumped in your sea level. If those are your sea surface, sometimes in your sea surfaces, or also some plastics are dumped, so they are also, they create some negative impact to your marine or other organisms present in your aquatic life. And if the plastics are present in your sea shore, basically they also sometimes go into your sand basin and sediment, and sometimes with slower decomposition they form the microfibers and they come to us, or there will be a cycle, they become a part of our day-to-day life. So this to avoid all these microfibers, this image is very like everywhere. If you try to find anything about pollution, then such images come to your eyes, and this really makes us think, or basically knocks our head, that we have to think, or we have to change some habits which can help us towards the sustainable uh, earth or world. So habits that can be changed, basically some habits are being changed nowadays. People are somewhat cautious compared to your previous uh, generation. I won't say generation, but yes, people are trying to give a thought towards their applications, towards using different products. They are seeing what type of plastic it is. They are seeing what is the basic thickness of this appliances, and what is the material. So some habits which we need to change, and there are some behavioral models are available. So one model which is thoroughly used, or frequently used, is proposed by Prochaska. So this trans theoretical model of behavior change is used to modify the consumption behavior of people. So there are basically 5 stages. This behavioral change this model can be applied for anything in the sense, for a drug addict, for a like alcohol means like that person, any kind of addiction is there. If someone is watching TV or mobile addiction, he such model can be applied for such applications also. And if some researchers have applied this Prochaska model to the behavioral change towards plastic, how people are behaving or how people are responding towards plastic, those this model is applied, and I'll be discussing those results also. This model is basically, it has some 5 stages. One is this one, like contemplation, that is where consumers are not bothered about any changing behavior. Then contemplation, where your consumers are sometimes like seriously considering. Then preparation, they are basically making themselves aware, or they are making themselves ready to try. Then action, they have put something towards the changes. Then some maintenance, so this change is maintained throughout. So when applying this particular model, I have taken this image or this result from this journal, which is published in 2019. Here you can see there are 4 images you can find from 1990 to 2019. So data are collected, and you can find there are like in 1990 there was packaging. Where is packaging? In 1990 there is no packaging. Then in 2000 there was 10% of sustainable packaging. It means people are giving a thought towards sustainable packaging. Then 2010 it increased somewhat. It decreased 8%. Then in 2019 it increased to 30%. So now we are in a stage where 30% people are giving a thought towards changing their approaches towards the usage of packaging plastic or single-use plastic. So this changing behavior, or we are in a stage where we need to analyze our behavior towards particular applications, because this 34% of single-use plastic is only creating the maximum pollution towards this environment. So we have to address that 30% first, then the remaining 66%, because 66% of other application areas are having the more life. They are not being dumped after just one use. So this behavioral change or changing people's behavior towards consumption of plastic product, it requires further development. Then you can motivate people to change somewhat, or like some approaches towards usage of plastics. Then there might be some, you can go and you can conduct some survey, you can conduct some workshops on plastics, its applications at your academic level, at your nearest your schools, or you can create some awareness among themselves. So I'll be then the last, or I'll be focusing on the what's next. The next is what I have started, like we have come to this plastic age, and we cannot just overthink, or we cannot discard this plastic in this way. We have to propose, we have to overcome, we have to give some newer innovative ideas, and we have to proceed further towards a newer or newer generation, where there won't be much, or people will be more aware towards your plastics and how to use them. It is not just a cheaper material which is being available easily so that we can just throw it away. Plastic has many reputation, and we cannot just make it so easily available. So this is the last one. We need to understand the full range of plastic impacts. Then we need to understand the plastic waste management, also the recycling, plastic policy, regulations, and other things. Then finally, the behavior change programs. Then only we can lead for a sustainable earth. Thank you. Thank you all for listening.
Thanks, Dr. Santoshi, for this talk. I think all the participants, they will now think about plastic from two aspects, the positive and negative both. So if any of you are having any questions, please feel free to ask madam, or you can write in the chat box.
Excuse me,
Yes.
madam, how FRP is made?
How?
FRP is made.
FRP? Yes.
Is made.
Yes. Madam, actually, fiber reinforced polymer composites or FRPs are basically, yeah, it has two components. One is fiber, another is polymer. So here what happens, you can take polymer can be of any grade like your thermoplastic or thermosets, but we sometimes because of the range of application we take the thermosets, we prefer the thermosets. So if you go for any thermoset polymer, usually we call them resin. So you can have the epoxy, just imagine of epoxy or USP like that. So you have the polymer which is basically liquid, and then the supplier provides you some kind of cross linking agent which on addition to this resin it will basically react or polymerization reaction take place. And you can have the second component is your fiber. So fiber can be your glass fibers you have seen. There will be your, that can be thread like structure, or there will be some powdery like sometimes those nano fillers or silica, or some powder basically nano fillers, those we call, we disperse them in your resin like the polymer, we disperse them in this polymer, then we add the catalyst and give some time for to react. There is basically some specification is given for each type of polymer by the supplier, like sometimes they have mentioned about room temperature reaction can take place for 6 hour or 8 hour, or sometimes they will refer for 8 hours at 80 degrees centigrade, like that. So if you provide the particular condition for reaction, then after you take it out, there will be the solid hard product. It means
Okay.
initially you have the liquid, you add the fiber, you add the curing agent, then you provided the appropriate reaction condition, then it will react, it will form the 3D structure and hard structure. Then you, when after this total cycle, you are taking out your product, that would be a hard, solid, rigid product. So depending on your application, sometimes what happens, those helmets and other things, they have a particular type of mold, like particular shape. So above that, you apply your this resin and fiber thing over your mold so that it will take the predefined, or basically it take the shape of your mold.
Okay. Okay. Thank you very much, madam. It was very informative session.
Thank you,
Thank you.
madam.
Madam, what will be now next? When will be the test conducted? Madam, any instructions about test?
Yes, madam.
Any instructions about test? When it will be conducted?
Around 4 p.m., madam. We have another session from 2:30 to 4.
Okay.
So then
There will
after,
be session from 2:30 to 4.
yes,
Okay. Then at 4 p.m. there will be test.
yes, for 30 minutes.
Okay. Okay.
Okay, madam.
Thank you.
Yes.
Excuse me, ma'am.
Okay, if
Where
there are
will
no
the
more questions, let's thank Dr.
excuse me,
Santosh Mohanta for this talk. So we
excuse
will
me.
break now for lunch, and we will rejoin at 2:30 p.m.
What will be the test format and where the link will be shared over the email or over the classroom inside this chat box only?